All right, so we are starting a new unit today, and this is our first trigonometry unit. And we're going to start by looking at angles and standard position. So some of what we will do today is a review of pre-calc 11, but we'll also look at a new unit of measure. And we're familiar with degrees. We're going to learn about radians today. And we're also going to look at measuring arc length of on a circle. So here we go. Angles and standard position. So consider a point P with coordinates x and y moving around a circle drawn on a grid with a center at 0, 0, the point of origin, and a radius of length r. So let's do this right here. So I'm going to call this point P, and it has some x and y coordinate. And I am going to create an angle here. It's got a radius of length r, and we wish to measure the angle between the line joining P to the origin and the positive portion of the x-axis. So I'm going to color this in as well. Here's the positive portion of the x-axis, and what we see is that we have an angle formed here, which I'm going to call theta. Theta is like the variable x, or any variable really. It just represents typically some unknown angle. So theta is from the Greek alphabet. It just looks like a 0 kind of with a line through it. Okay, so we say that this angle is in standard position. So an angle in standard position is measured from the initial arm. Let's label that. This is the initial arm, and the initial arm is the positive portion of the x-axis. And if it's a positive angle, it's measured counterclockwise from the initial arm to the terminal arm. So this is what we call the terminal arm. So the initial arm is where the angle initiates, and the terminal arm is where the angle terminates. Okay, so let's fill in some of these things. So the positive portion of the x-axis is that's where we begin. That's our 0 degree mark. Okay, angles have their vertex at the point of origin. So this is at coordinates 0 and 0. Okay, positive angles are measured counterclockwise. And negative angles are measured clockwise. So we'll really hammer that point home today. Okay, so the arm on the positive portion of the x-axis, as we talked about, is called the initial arm. And the other arm is called the terminal arm. So just one other point of reference. So we're talking about angles in standard position. And again, an angle in standard position is measured from the initial arm. It initiates at the initial arm, and the initial arm is the positive portion of the x-axis. And so that angle is measured, if it's a positive angle, it's measured counterclockwise to the terminal arm. And if it's a negative angle, it's measured clockwise to the terminal arm. So I'm just going to give you an example of another angle. You don't necessarily need to write this down. Let's just do something like this right here. So sure, this is also an angle, but that's not an angle in standard position. So it's actually not something that you would see. We're going to work with angles in standard position primarily. So I'm just going to erase that. Okay. So degree measure. The measure you are familiar with is degrees. So one full rotation is 360 degrees, and 1/360th of a rotation has a measure of 1 degree. Okay, so we're going to start by drawing these different angles, and we'll make sure that we're drawing all of them in standard position. Okay, so we'll start with a 60-degree angle. So in standard position, that means it is initiating at the initial arm, which is the positive portion of the x-axis. And this is a positive angle, so we're going to measure counterclockwise. And we don't have to be perfect here. We just need to make sure we're in the right quadrant. Okay, so 60 degrees is going to be something like this, and we have rotated counterclockwise from the initial arm, and I'll just label that as being 60 degrees. Okay, -40 degrees. So again, this is an angle in standard position. So it initiates at the initial arm, positive portion of the x-axis, and it's a negative angle, so we're now rotating clockwise. Okay, so I'm gonna do something like this. We'll label this as being -40 degrees. So we've got -40 degrees, and we have rotated clockwise from the initial arm to the terminal arm. Okay, and same idea with -490 degrees. So this is an angle in standard position. So it's going to initiate at the initial arm, positive portion of the x-axis, and it's a negative angle, so we're rotating clockwise. Now we are going beyond 360 degrees, or going beyond -360 degrees. So we're doing one complete rotation and then a little bit more. So -490 degrees is going to end up in quadrant 3, and it's going to look something like this. So we're initiating at the initial arm. We're doing one complete rotation and a little bit more, and so we can label this as being -490 degrees. Okay, so moving on. Radian measure. So we are used to working with degrees. What is a radian? So the definition of a radian. One radian is the measure of an angle containing an arc of length r in a circle of radius r. So let me try and diagram that for you a little bit here. Okay, so here's our circle. Here's the center of our circle. I'll do the best job I can do here. So we would agree that what I've just drawn is a radius. And here's another radius. So I'm going to label the radius as having a length of r. And of course, they will both have the same length. So here's the definition of a radian. Now, this distance right here is something that we call arc length. Okay, so it is the measure of a piece of the circumference of the circle. Okay, so 1 radian is this angle right here if the arc length is equal to r. Okay, so we've got the radius of the circle is equal to the arc length. The angle contained in that arc length has a measure of 1 radian. Okay, so a circle has 360 degrees. The circumference of a circle comes from the formula 2 times pi times the radius. So if the radius was 1, then the circumference is 2 pi. Okay, so one complete rotation about the unit circle is an arc length of 2 pi for every 360 degrees. Okay, so one of the things that we will come to realize is that 2 pi radians is equal to 360 degrees, and we can work with different fractions off of that. Okay, so 2 pi radians is 360 degrees. Half of that is pi radians, which would be half of 360, or 180 degrees. Okay, so we're going to draw some additional angles here, but these are angles measured in radians and not so much, well, they're not degrees, okay? They are radians. So before we do that, what I'm going to do is we know that this is 0 degrees, and it's also 0 radians. If we were to do, and be prepared to erase some of this, if we were to do one complete rotation, that would be 360 degrees. And maybe I'll just do this in red. So this is also 0 radians, and one complete rotation in radians is 2 pi radians. Okay, so we're going to work off of that. This is 180 degrees, and in radians it is pi radians. Okay, maybe I'll grab a third color here. Now we want to draw pi over 3 radians. Okay, we want to draw that angle in standard position. Okay, so the next thing I'm going to do is, hopefully you will agree with me that 3 pi over 3 is an equivalent fraction to pi. Okay, so we can think about that as being 3 pi over 3 radians. And if we're doing that, so this is the angle 3 pi over 3 radians, okay, which we know is 180 degrees. But let's break that up into 3 equal parts as best we can. Okay, so there's our 3 equal parts. So here's what we're doing here. This is going to be pi over 3 radians. Okay, so that's a positive angle. It's been measured counterclockwise. So this would be 2 pi over 3 radians. I know we didn't need to include this, but it may be helpful. And then we've got 3 pi over 3 radians. Okay, so there's our pi over 3 radians. Okay, and we'll do the same thing with pi over 4 radians. Okay, so this is an angle in standard position, so it's measured from the initial arm. Okay, our reference point is thinking about, okay, where is pi radians? Pi radians is 180 degrees, so we need 1/4 of that. So that's going to be right here. So this is pi over 4 radians, and you may be thinking to yourself, well, that's 45 degrees, and you would be correct. Okay, negative 3 pi over 4. So same idea. This is an angle in standard position. It initiates at the initial arm, which is the positive portion of the x-axis. If we were to do... Now we can think about a half rotation clockwise, so a negative angle. This is going to be negative pi radians. But we could also think about that as being negative 4 pi over 4 radians. So negative 4 pi over 4. So we need to think about where negative 3 pi over 4 is going to be. And that's going to be something like this. And we've rotated clockwise because it's a negative angle. And we'll label that as being negative 3 pi over 4. Okay, how about 5 pi over 6? Angle in standard position. We can think about 180 degrees as being pi radians, or 6 pi over 6 radians. So something like this would be 5 pi over 6 radians. Positive angle we've measured counterclockwise. Okay, same idea, 7 pi over 6, we've gone just beyond pi, or 6 pi over 6. So let's label this as 7 pi over 6, and we've measured it counterclockwise. Okay, and then negative 5 pi over 3 radians, more or less the same idea. Let's think about, and I'll erase this in just 1 second, one full rotation clockwise, that's negative 2 pi radians. As an equivalent fraction, we can think about that, I'll just put it in brackets, we can think about that as being negative 6 pi over 3 radians. So where's negative 5 pi over 3? Well, that's going to be in quadrant 1. Something like that, negative 5 pi over 3. And we've measured clockwise. Okay, so here are our conversion factors. If we want to convert an angle from degrees to radians, we're going to multiply that angle by pi over 180. And if we want to convert from radians to degrees, we're going to multiply that angle in radians by 180 over pi. Okay, so converting 30 degrees into radians, we're going to multiply by pi over 180. So we would get 30 pi over 180, which simplifies to pi over 6, and that is an angle in radians. Okay, 90 degrees. Again, we're multiplying by pi over 180. That's going to give us 90 pi over 180, which simplifies to pi over 2. Okay, and same idea, we'll just continue to multiply each of these by pi over 180. This is going to become pi over 4 radians. We know that 360 degrees is 2 pi radians. 110, we're going to get 11 pi over 18. And 270 degrees becomes 3 pi over 2 radians. Okay, so we often leave radians in terms of pi. So the units for radians are either radians or nothing. Okay, so you see in that last example there, 270 degrees is equal to 3 pi over 2. You don't see the unit. Now, we could write radians, but in the absence of that, we can assume that the angle is in radians. Okay, so the units for radians are either radians or nothing. So if an angle measures pi over 2, then we can assume that we are working in radians. Okay, converting from radians to degrees. So now we're multiplying by 180 over pi. So we'll just multiply this by 180 over pi, and if we were to plug that into our calculator, we would get something like 57.3 degrees. So next one, we're converting 5.6 radians into degrees. We're going to multiply by 180 over pi. And if we plug that into our calculator, we should end up with something like this, 320.9. And that's an angle measured in degrees. Okay, and 5 pi over 6, same idea, multiply by 180 over pi. We end up with 150 degrees. And 3 pi over 4, we end up with 135 degrees. Okay, coterminal angles. So coterminal angles are two or more angles in standard position with the same P position. Okay, so I'm just going to give you a quick diagram. There's the definition. I'll give you a visual of that definition. So let's take this angle right here, measured in standard position. So measured from the initial arm to the terminal arm, we're rotating counterclockwise. Let's call this a 60-degree angle. Okay, now here's the idea of a coterminal angle. If we were to continue rotating an additional 360 degrees, that would take us right back to the exact same angle in standard position. Okay, what would its measure be? Well, we're adding 360 to 60, so it would be 420 degrees. Okay, so both of those angles have the exact same standard position, and so that's the idea of a coterminal angle. And one of the neat things about coterminal angles is they share all of the exact same trigonometric properties. So if we were to take the sine of 60 degrees or the sine of 420 degrees, we're going to get the exact same thing. Okay, so find two angles that are coterminal with 40 degrees. Okay, so we can either add 360 degrees to find coterminal angles. Okay, so that's going to take us to 400 degrees and 760 degrees. Okay, so each of those angles is coterminal with 40 and coterminal with each other. Okay, we could also subtract 360 degrees. Okay, so we're going to get negative 320 degrees and negative 680 degrees. So those angles are coterminal with 40, and they're all coterminal with each other. Okay, this angle is given to us in radians. So find two angles that are coterminal with pi over 4 radians. Okay, instead of adding 360 degrees, we're going to add 2 pi radians. And it might be helpful to think about 2 pi as an equivalent fraction. So we could go 8 pi over 4 radians. So if we're adding 8 pi over 4 radians, we have coterminal angles of 9 pi over 4 and 17 pi over 4. Okay, we could also subtract 2 pi radians. So we would get angles of negative 7 pi over 4 and negative 15 pi over 4. So all of these angles are coterminal with pi over 4 radians, and they're also all coterminal with each other. Okay, so to summarize, just leave a little note here. To find coterminal angles, we can either add or subtract 360 degrees. Okay, so that's if we're working with an angle in degrees, or 2 pi, and that's if we're working with an angle in radians. Okay, so given any angle theta, any coterminal angle is represented by this, and we call this a general solution. So in degrees, we could say theta plus 360 times n, and we're going to specify, we're going to say this, n, e, z. Okay, and and that probably looks somewhat familiar. You often have seen something like this, XER. X is an element of the set of real numbers. What does NEZ mean? NEZ means that N is an element of the set of integers. Okay, so N is an integer is what this means. Now we have to remember what an integer is as well. Integers are counting numbers that include both positive numbers and negative numbers, as well as 0. Okay, so like -3, -2, -1, 0, 1, 2, 3, those are all examples of integers. Okay, in radians, we would say the general solution for finding coterminal angles is we would take theta, that is our angle that we're working with, and we're going to add 2 times pi times n, and we would say that n is an integer. Okay, so just as an example, we'll do this. Let's say that theta is equal to, I don't know, 20 degrees. Okay, and let's say that n is 2. Okay, that's an integer, that works. So this is going to help us find a coterminal angle with 20 degrees. So we're going to do theta, which is 20, plus 360 times n, which we have made out to be 2. Okay, so we've got 360 times 2 is 720, plus 20 is 740. So 740 degrees is an angle that is coterminal with 20 degrees. Okay, so let's work with some of these graphs here. So draw the given angle and then draw 2 coterminal angles and find their measurements. Okay, so again, these are angles in standard position. So 150 degrees initiates at the initial arm, which is the positive portion of the x-axis, and it's going to be something like that. So we'll call this 150 degrees. We have rotated counterclockwise. It's a positive angle. So if we continue to rotate an additional 360 degrees, we come right back to the exact same angle in standard position. But this angle is going to be 510 degrees. So I've added 360 to 150, so 510 degrees is coterminal. And let's go one more. We need to find 2 coterminal angles. If we continue to rotate another 360 degrees, we end back up in the same standard position, add another 360 to 510, we have 870 degrees, and all 3 of those angles are coterminal with each other. Okay, -pi/3 radians. Okay, so in standard position, measuring clockwise. So this is something like -pi/3 radians, and we can continue rotating another 2 pi radians. Okay, we're working in radians now. So we're subtracting 2 pi radians from this to find the next coterminal angle. But let's think about 2 pi radians as an equivalent angle, but with a denominator of 3. So that's going to be -6pi/3. So our coterminal angle, is going to be, where is it? -pi/3 minus 6pi/3, -7pi/3. And let's go one more. Rotate another 2 pi radians. We're going to get -13pi/3. So all of those angles are coterminal with each other. Okay, and the last thing here is finding the length of an arc in a circle of radius r. Okay, so we have to, this is working with arc length. Okay, now to begin, I'm just going to draw a circle. Okay, we're going to derive a formula ourselves. A formula for determining arc length. Okay, so we've got a circle, and I'm just going to draw a central angle here. Okay, so this central angle I'm just going to call theta. Okay, now what is arc length? So arc length is the measure of the circumference of the circle contained by that central angle theta. Okay, so this is arc length, and arc length, our shorthand for that is A. Okay, so we had talked about this earlier. Our formula for the circumference of a circle is 2 times pi times the radius. Okay, now I want us to think about an idea here. Arc length is a portion of the circumference of a circle. Okay, and the circumference of the circle comes from 2 times pi times the radius. Okay, now this would need to be proportionally equal to, so arc length as a portion of the circumference of the circle, 2 pi r, would need to be proportionally equal to some central angle theta as a quantity out of 360 degrees. Okay, so 2 pi r is the circumference, or the length, the perimeter around the circle. 360 degrees is one full rotation. So the arc length as a quantity of the circumference would be proportionally equal to the central angle theta as a quantity of 360 degrees. Okay, so deriving a formula here for arc length, let's solve for A. And if we can multiply both sides by 2 pi r, we get that arc length is equal to theta divided by 360 times 2 times pi times the radius. Okay. Now, this is a formula for working with an angle in degrees. Okay, what would we change if we were working in radians? That 360 degrees, or that 360, would become 2 pi radians. Everything else remains the same. But what we notice here is that these 2 pi's cancel each other out. So our arc length formula becomes theta times. Okay, and so this is our formula in radians. Now let's apply this to some different examples. Okay, so we're told that a circle has a radius of 8 centimeters, and we want to calculate the length of the arc subtended by each angle. Okay, so the first one is 2.3 radians, and the second one is 75 degrees. Okay, so in radians, our arc length formula, arc length is equal to theta times r, and in degrees, our arc length formula is equal to theta divided by 360 times 2 times pi times the radius. Okay, so circle has a radius of 8 centimeters, so r is 8. Calculate the length of the arc subtended by each angle. So we're looking for A. First one, theta is 2.3, so we're going to go A is equal to 2.3 times 8. So we get an arc length of 18.4 centimeters. And the second one, we get arc length is equal to theta is 75 degrees, so 75 divided by 360 times 2 times pi times the radius, which is 8. And if we calculate that out, we get 10.5 centimeters. Okay, and the last two here. So a circle has a radius of 5 centimeters. So r is equal to 5. Find the angle at the center containing an arc length of. So this time theta is our unknown. So the first one, we are looking for theta in degrees. So here's our formula again. Theta divided by 360 times 2 times pi times the radius. And the second one, we're looking for theta in degrees. So arc length is equal to theta r. Okay. So circle has a radius of 5 centimeters. Find the angle at the center containing an arc length of. So in this case, arc length is 6 centimeters. So we're going to do 6 is equal to theta, which is our unknown, divided by 360 times 2 times pi times the radius, which in this case is 5. And if we work that out, we get that theta is equal to 68.8, and that's an angle in degrees. And then finally, we've got the arc length here is equal to 15 centimeters. Theta is our unknown times the radius, which is 5. So we get theta is equal to 3, and that is an angle in radians.